here's a triangle, and I have my 3 altitudes drawn. I have my 3 altitudes drawn. Now, by definition, we can see so the red lines are your altitudes. By definition, it says starts at a vertex and goes to the opposite side and is perpendicular. Okay, so clearly your red segments are your altitudes. Starts at vertex, goes to opposite side, and is perpendicular to that opposite side. And finally, here's our last one. Now we know that it doesn't have to be a segment. We can extend those segments to make rays or lines. What this program currently has is lines. These segments are extended. So I want us to see just what is the effect as the interior angles start changing. Right now, this is an acute triangle. Every single angle measurement, or the interior angle measurements, are less than 90 degrees. That means that this orthocenter is going to be inside the triangle. The orthocenter is going to be inside the triangle. And remember, the orthocenter is the point of concurrency for the altitudes. That's where all 3 of these altitudes are going to intersect. Now, what I'm going to do is I'm going to change angle A. So right now it's acute, but as I start approaching 90 degrees, that orthocenter is getting closer and closer and closer to vertex A. And then finally, when I make angle A a 90-degree angle, we can see that that orthocenter is right on that vertex of that right angle. The reason for that is because in a right triangle, the legs, the sides that form that right angle, okay, those are called the legs, they intersect at that vertex of your 90-degree angle, and they're perpendicular to one another. So if I want to know the altitude or the height, and when I consider this to be my base, then you start at a vertex and you go to the opposite side and perpendicular. And so this was this example that we did together. So here's my hypotenuse, this is a leg, that's a leg. Well, my legs are already perpendicular, and they go from vertex to the opposite side, and they are already perpendicular. So when you have a right triangle, you automatically already have 2 of your altitudes. The third one starts at that vertex and then goes down to that hypotenuse and is perpendicular. So this is what I mean when it's on that chart and it says it could be on the triangle, meaning when you have a right triangle, that orthocenter is going to be the vertex of your right angle. Now I'm going to keep making angle A larger and larger, making this an obtuse triangle. When you have an obtuse triangle, that altitude starts to go outside of the triangle. Starts to go outside of the triangle. That's why it's important when if you look at the definition that's on your flip book. On your flip book, you should have written that it is a segment that starts at the vertex, so starts at vertex C, goes to the opposite side, or the line containing that opposite side. So this light baby blue line here that they've extended, that's the line that contains that side. And so they've had to extend this side a little bit so that this altitude could be perpendicular to it. And so sometimes that orthocenter is going to be outside of this triangle when it is obtuse. And you guys have seen this before. You've come across these heights of obtuse triangles before. Maybe it was in 7th grade or 8th grade, or maybe on some standardized test. But let's say you had this triangle and you needed to find out the area of this triangle. Well, the area of a triangle is 1/2 times base times height. Maybe some of you learned base times height divided by 2. Same exact thing, because we know that multiplying by 1/2 is the same thing as dividing by 2. Right? Cool. So we need to figure out, well, what is the base of this triangle and what is the height of this triangle? What they would do is, on standardized tests, they would always try to fool you and say, well, let's say this is 20 feet, and then this is 17, and then this is 11. And so you have all 3 side lengths of the triangle, and then they would draw something like this, where this is an extension, and you have this extension, and this is perpendicular, and they would tell you, well, this is 12, and then this one is 10, so on and so forth, and they would say, find the area of this triangle. And you'd have to figure out, well, what is my base? What is my height? Well, the thing is that your base and your height must always be what? Base and your height always has to be perpendicular. So you need to find two distances, two lengths that have to deal with this triangle, the base and the height, that are perpendicular to one another. Well, if we consider this side that it's sitting on, if we consider that to be the base, then the perpendicular distance from the tip top here straight down to that side would be 10, would be from this vertex straight down. That is the perpendicular distance. And so you'd have to say, well, the area is 1/2 times 11 times 10, which would give you 55 square units. Well, this is one of your altitudes. So in your definition, it should say that it goes from vertex perpendicular to the opposite side, or the line containing that opposite side. Because we know that there exists a line here that will go through that side, and it contains that side. And so your altitude is going to actually be perpendicular to the line containing that side. It's never going to really touch that side. So this would be my altitude in blue ink. Sometimes these altitudes are going to be outside of your triangle. That's fine. It just means you have an obtuse triangle. So, finally, now, let's look at the Springboard textbook, page 191, and let's dive into it and get some of these equations figured out. Now, what it does in Activity 14-1 is they create this elaborate story about treasure hunting, and it's buried, and they gotta find it, and they also have to find themselves in this adventure. No, I don't know. But we're not going to mess that. We're just going to find these equations. So we're going to skip all of page 191, and we're going to jump to page 192, where we actually get into the meat of the mathematics. If you look on the top left of that page 192, it, again, defines an altitude of a triangle for you. So you've got it in your flip book, you got it in your chart, and you got it in your Springboard textbook. It is all over the place. There's no reason why you should not have this memorized or know where to locate the definition. Remember, what does the definition tell us, or how is the definition going to help us write the equation of these lines?
So that the vertex goes to the opposite side and the equal perpendicular side.
Right, so in order to write the equation of two lines, in order to write the equation of one line, we need two facts. First thing, we have to know the slope. Well, this definition says that it's perpendicular to that opposite side. We can find that out, especially if we're given the coordinates. The second thing you need to know is at least a point that it goes through. It doesn't necessarily have to be the y-intercept, but you need to have a point that it goes through. And we know that it has to go through the vertex. So step one, if I want to find the equations or graph the three altitudes of any triangle, these are the steps we got to go through. Item 1 on this page, it says determine the slopes of the three sides of triangle AGC. Please do that on your own right now. You can either use the slope formula or it's graphed. Just count. But we need to figure out what is the slope of these sides. Alright, real quick and easy. What is the slope of segment AG? Notice my notation. I've got lowercase cursive m for slope, and then subscript segment AG. So when someone reads this, it's clear what slope I'm talking about. If on your paper right now, if you have m equals, m equals, m equals, how is a person supposed to look at your book and know what you're talking about? You got three slopes? Well, which one goes with which? Okay, so use these subscripts to help you just organize your work and make it readable. So I've got the slope of segment AG. This is one side of this triangle. What is the slope of this segment? Say it. 0, right? 0. Good. Horizontal. Horizontal with a Z has a 0 slope. Keep your Z's together. Let's go over here to segment AC. What is the slope of segment AC? Positive 2. We know that has a rise of positive 2 and a run of positive 1. We can simplify that and just say it's positive 2. Then over here, the slope of segment CG. Before you yell something out, just look at it. Is that positive or negative? It's a negative slope, okay? So make sure that your answer makes sense. This has to be a negative slope. Look at it. So what is its value? Negative what? Negative 1. This has a slope of negative 1. Wonderful. All right, now let's look at item 2 and see what it says. Item 2